Class example 3.4.4. For each graph, first, we're going to say, does the graph describe a relation? Second, is this relation a function? And then we're going to give the domain and the range using words and interval notation as well as set notation. So first of all, if it is a graph, it is going to describe some sort of relation. This one looks like it's going to be a linear relation. This one looks like it's got a couple of curves here. These are half parabolas. You'll learn those next year when they're on their side. But yes, both graph A and graph B are relations. Now, we said that a function is a special type of relation, and that special type of relation means that there's only going to be a single output for each input. We like to also say this could be a single y value for every x value. Sometimes we call this the vertical line test. I save that kind of till the end only because we don't always have a graph. So we don't even know if it's going to pass a vertical line test until we actually visualize it. So this last one I kind of leave to the end. So in our first one, graph A, we can see that every individual value for x, -2 has only one output. In fact, it doesn't have any output because it's an open dot. -1 has one output, 0 has one output. You can just kind of follow my pen line and I can go anywhere along the x-axis. And when I draw a line either up or down to my actual graph itself, I only have one y value that could actually correspond to it. Down here, I'm going to draw the graph. Sorry, if I go to anywhere on the x-axis and I draw a line down to the graph, there's only one output. So graph A is a special type of relation called a function. Graph B, on the other hand, is not. Let's just go to where x is equaling to 2 for a moment. I have 2 y values when x, and that's not okay. So therefore, graph B is not a function. Now, for part C, we're going to give the domain and the range. And we're going to do this a couple of different ways. Okay, for graph A, in words, we know that we are going to have an arrow at the end of this graph, which means that the x values, if I was to draw this larger and I could actually extend this x-axis out forever, my graph itself is also going to continue forever, but it has a stopping point. Okay, the stopping point happens to be when x is equaling to -2. Now don't forget, we're talking about domain first. And domain is all associated with the x values. Okay, we'll deal with range in a second. And range is going to deal with the y values. Again, alphabetical order to remind ourselves which one goes with which variable. So if I look along the x-axis here, if I was to extend out that x-axis all the way till who knows when, I can see that it has a stopping point at -2. I also see that it has an open dot. So our domain is going to include all values of x larger than -2. Okay, doesn't include -2, so that's why we said larger than and not including. Okay, for our y values, we can again see, okay, we've kind of got this stopping point. So it's almost like I'm trying to squish this red graph onto the y-axis. But I can also see that it's got an arrow and it's going to continue up. So I could continue up, 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 and I would never be able to stop here. It's not going to magically stop at like, I don't know, 1,358,000 or something random like that. It's just going to keep going on forever. So our range values include all values of y larger than, and I can see it goes all the way -1, -2 to -3. Okay. So if we're going to continue, and this is just graph A right now. This was graph A, sorry. If we're going to use this interval notation. An interval has a start and a stop. Okay, so we always start where, if we were reading a book, like going from left to right, or always smallest to largest. Okay, we have a square bracket if it's including, and we have a round bracket if it's excluding. And an arrow that goes on and on and on and on and on and on and on forever, we represent with an infinity sign. If it's going in the positive direction, we represent it with a positive infinity. If it's going in the negative direction, we represent it as negative infinity. So for graph A in interval notation, for our domain, I am going to start at -2 is my smallest answer, or sorry, my smallest value, and I'm going to go on and on and on to infinity. Now, -2 does not include, because it is not included because it has a circle or an open dot at that point, okay? But an infinity sign always gets a round bracket because there's no such thing as including infinity. Infinity is just a symbol to represent that it goes on and on and on forever. So we actually put a round bracket around the infinity sign as well. For our range, we're going to start at the smallest number. We already did this in words. That's -3. I see it's an open dot, so I have a round bracket, and it's going to keep going on and on and on forever. So for my domain and range and interval notation, I go from -2 to positive infinity, not inclusive. And for my range, I go from -3 up to positive infinity, not inclusive. Okay. Now, if we were to do set notation, for some reason, is a little bit more complicated. Right? We still start with our domain and range. We're going to go back to those squiggly lines like we've done in previous questions where we've got a list, okay? But in this particular case, we've got some notation that we care about. We are talking about the domain, so we would write X, okay? This really elongated line here means such that. So we would have a line that says X such that, and then we would have what is X allowed to be? Well, X includes all the values larger than -2. So we would say X is going to be all of the values greater than -2. But the problem here is we don't know if it's going to be -1.5, -3/4, +1,000,000 decimal 9999999. So it actually, because it's a solid line, it includes all of the possible values. And if you remember back from our very first chapter, we talked about the number system. And in the number system, when we include decimals and fractions and positives and negatives, we include rationals, we include irrationals. So even the square root of 2 is on this line somewhere. It's 1.4-ish, somewhere around here. All of those things are in the real number system. So we say that X, we give this weird E. It's not an E. Please don't say an E. It's an element. It says is an element of. And we say the real numbers. Now, I know we've seen this symbol before, the real numbers. Okay, we don't get to complex numbers in high school. You'll get to complex numbers in university if you so choose to continue with math. But for us, we're going to say X is an element of the real number system. That's what these three symbols together mean. XER is not how you say it. You say X such that X is going to be an element of the reals. Okay, so we're going to do the same thing for the Y. We're going to open up our squiggly lines. We're going to talk about range. So therefore, we're saying Y such that. We've already said that Y has to be greater than -3. Notice I don't have my equal sign. It's the same as my round bracket, right? It's because there's an open dot over here. And then I'm going to say Y, because it's a solid line, is going to be an element of the reals. And that's a little bit more things. It's like 3 separate sections. First, we're indicating what we're dealing with, right? Domain is dealing with X, range is dealing with Y. then we're actually giving the rule or the specifics, right? X had to be greater than -2 and Y had to be greater than -3, but we're adding an extra piece of information on here. And this extra piece of information is telling us what number system it's allowed to be. It tells me I'm allowed to draw a solid line, unlike the lists that we've had in our previous questions. Okay, graph B. Just because graph B isn't a function does not mean I don't get to actually talk about the domain and the range, right? Domain is just all the values that X is allowed to be, and range is all of the values that Y is allowed to be. So we still have a physical graph in front of us. So what I'm going to do is I'm going to work around this X axis because I'm going to look at the domain first. And I can see it's got a starting point and it's got a stopping point, okay? I also see that the line itself is solid. So my X values are allowed to be 0. I'm allowed to have a 1, a 2, a 3, a 4, 5, or I'm allowed to have like a 2.3, maybe the square root of 2. What about pi? Pi is 3.14. That's in there somewhere, right? So I am going to say in words for my domain, the domain includes all values of X between 0 and 5. I could write those numbers out as ZERO and FIVE, whatever. Okay, so let's take a look at the range. The range is a little bit trickier because it actually has an open dot and a closed dot. So in this particular case, I've got a closed dot on the number 2. And if I'm looking at the Y values, I can see I've got an open dot up here. And then, of course, just like we had in the domain, because it's a solid line, I'm allowed to go with all of the values in between then. So I can have a 2, I could have a 3, I could have a 4, I could have a 5.782394, whatever I want. I can have a 6, but I cannot have a 7. So we are going to have a different way to write our range. The range includes all values of Y between, we're going to write between 2 and, I'm writing 7, but I'm going to add something else. You could write this a different way. You could say from 2 all the way up to 7, but not including, and I'm going to say exclusive of 7 itself. Okay, so anything in between 2 and 7. So it could be 6.999999999, but it cannot be 7. Okay, so let's talk about this in interval notation. I'm going to start with the domain. Domain, we had including the 2 and all the way up to the 5. So we're actually going to start at the smallest number, go to the largest number. And because there was closed dots around 2 and, between 0 and 5, it says it right here, sorry. Because there was closed dots on 0 and 5, I'm going to keep that 0 square brackets around both. That means that they were including. And our range, we're going to go from our smallest number, which is 2, up to our larger number is 7. We had a closed dot around 2, but we had an open dot around 7. So now my interval notation is going from smallest to largest. But in this particular case, I have a square bracket and a round bracket, depending on which end of the interval I'm looking at. Set notation. The thing with set notation is that some of it's kind of systematic, right? Whenever we're talking about domain, we're going to get a squiggly line and write X such that, because that's what we're physically talking about is the domain. Then same thing happens with the range. Whenever we're talking about range, I'm always going to get that Y such that symbol going on. So that's not, you're not really thinking outside the box here. You're just putting a couple of mathematical symbols in here, and I'm saying the words as we're writing the symbols. Now for X, we still use that interval notation starting at the smallest to the largest. We're going from the smallest to the largest, but this time we write it when we with inequality symbols like we've done in Math 9. So now I can see that whenever I have a range in between two values, I start with the smallest, I go to the largest, and then I think, were they included or not? So this says all X values greater than or equal to 0, as well as all X values less than or equal to positive 5. So again, smallest to largest with some inequality signs in between. And then because, and you see this a lot, particularly in all Math 20 and 30, We don't have a lot of the times where it's not a solid line in between. So we write that x is an element of the reals at the end and then close my squiggly line. For the y values, again, we're going from the smallest to the largest. I'm dealing with y. I know that I'm always going to face those inequality signs to have away from the smallest and towards the largest, right? Just like the alligator, like when you were little. I don't know. He always eats the larger number, right? Okay. Anyway, in this particular case here, I'm allowed to equal to the 2 because it had a closed dot, but I don't put that equal sign on the 7 because it was not included. It had an open dot. And of course, we're always at the end because it was a solid line, right? That y is equal to y is an element of the reals.